Imagine entire planets being stripped of their atmospheres, their potential for life extinguished by forces beyond their control. That's the chilling reality of exospace weather, a phenomenon we're only beginning to understand, and it could determine whether life exists beyond Earth. Space weather, those powerful forces emanating from stars, is a major, yet often overlooked, player in shaping the destinies of planets. We see its effects in our own solar system, beautiful auroras like the northern lights, but also atmospheric loss and chemical changes. But here's where it gets controversial. While we can directly observe space weather's impact on planets within our solar system, understanding its influence on exoplanets, planets orbiting other stars, is a monumental challenge. We're essentially trying to predict the unpredictable with limited tools and data. The difficulty stems from our inability to directly measure crucial elements like stellar winds, streams of charged particles, coronal mass ejections, huge bursts of energy and plasma, energetic particles, and the ever-changing interplanetary magnetic field surrounding these distant worlds. It's like trying to understand a hurricane without radar. This challenge sits squarely at the intersection of four vital scientific fields: heliophysics, the study of the sun's influence; planetary science; astrobiology, the search for life beyond Earth; and astrophysics. These fields must work together to crack the code of exospace weather. Recognizing this critical need, between 2023 and 2025, experts from these diverse disciplines gathered at the W.M. Keck Institute for Space Studies, KISS, to brainstorm ways to advance our understanding of exospace weather. The team organized their efforts around 5 core themes, each representing a critical piece of the puzzle. These themes included the interaction between exoplanets and the stellar particle environments they inhabit, modeling stellar magnetism and its role in generating space weather, the impact of relatively constant stellar winds, the effects of transient events like solar flares, and finally, outlining practical steps to make progress in the field. This collaborative effort resulted in a comprehensive report, a synthesis of knowledge and ideas from across these fields, highlighting both the challenges and the opportunities for advancing our understanding. And this is the part most people miss. The report doesn't just summarize what we know, it identifies the biggest theoretical gaps in our knowledge, explores promising new technologies in observation, modeling, and instrumentation, and proposes concrete recommendations to accelerate progress across the entire scientific community. This includes things like developing new telescope capabilities, refining our computer models of stellar activity, and creating standardized methods for analyzing data. Ultimately, this report provides a roadmap for transforming exospace weather from a daunting problem into a manageable and crucial element in our quest to understand exoplanetary systems, and even our own solar system, in their entirety. It's about connecting the dots between stellar activity and planetary habitability. The report, authored by R.O. Park Lloyd, Evgenia L. Shkolnik, Joseph Lazio, Greg W. Hallinan, Julian Alvarado Gomez, Laura Amaral, Ivy Davis, Allison Farish, James Green, Dave Brain, Bin Chen, Christina Cohen, Shannon Curry, Karen Dissauer, Erica Egan, Nat Gopalasvami, Guillaume Granoff, Shadia Habel, Renyu Hu, Meng Jin, James Paul Mason, Ruth Murray Clay, Kosuke Namakata, Rachel Austin, Antigona Segura, Astrid Verenig, Aline Vidato, Maurice Wilson, and Yusu, is a substantial document. Spanning 170 pages and including 55 figures, complete with a table of contents, references, appendices, a glossary, and an index for easy navigation. This research is categorized under instrumentation and methods for astrophysics, astro-ph.im, Earth and planetary astrophysics, astroph.ep, and solar and stellar astrophysics, astro-ph.sr. You can cite this work as AR14, 2511.02871 astro-ph.im, or AR14, 2511.02871 v1, astro-ph.im, for this version. The DOI is https://doi.org/10.48550/arcs4.2511.02871. The journal reference is 2025 W.M. Keck Institute of Space Studies, KISS, California Institute of Technology. A related DOI can be found at https://doi.org/10.26206/gmhk5-amp17. The submission history shows that the paper was submitted by R.O. Park Lloyd on Tuesday, November 4, 2025, 3:20 and 57 seconds Universal Time Coordinated, 14,052 kilobytes, and is available at https://arcs4.org/ab/2511.02871. So, what do you think? Is exospace weather a critical factor we've been underestimating in the search for life beyond Earth? Could it be that some potentially habitable planets are being rendered lifeless by stellar activity? Or do you believe that planets can adapt and thrive even in harsh space weather environments? Share your thoughts and opinions in the comments below.